right now, it's going to be a presentation between now and lunch, so we're going to try to make it as dynamic and exciting as we can be. And certainly in a topic that not a lot of people are familiar with, which is how do I try to regulate a very creative, very effervescent industry based on the fact that there are new technologies coming out every day? Is there actually a process? Is there a framework that we can follow that would allow us to actually achieve such objectives? So today what we're going to talk about is very simple conversations in regards to the fact that there are many, many changes happening around the world right now in real time. A few weeks ago, someone told me that they had noticed 781 different table regulations being adopted. We also are going to be looking at how do different other regulated industries have navigated the ability to impose potentially some restrictions for the concepts of human safety and looking at other types of reliability that needs to be implemented within the various systems. And we're also going to talk about the perspective of treating AI as an engineering endeavor. Are there tools and techniques that I can use that encompass the engineering ethos so that I can actually build better products faster? What we're not going to touch on today is, even though there's a lot of changes happening around the world in real time, we're not going to make any conversations about ethical AI. So although you will see those terms, we're not going to be actively discussing it. That's a separate conversation. There are some other talks today talking about this. We're not going to talk about the geopolitical differences, the fact that Korea came out with AI for defense well before it was accepted. And with the Ukrainian conflict, we've seen that there's actually been a need for those technologies to come up to the battlefield. So we're not going to touch on that. We're just going to say that there are actually some differences in a very heterogeneous landscape that comes to AI adoption around the world. And we're not going to specify against any type of abolition or canceling any types of projects right now. We're just going to talk about how would you go about building it. So what is regulated AI for the purpose of this presentation? Well, first, it's three things. It's an approach of how to use AI within regulated industries. So a regulated industry is just where there's a legal requirement for participation. Building a car, building a medical device, building a plane, all of those need to have certain levels of certification. That's really what we're talking about here. We're going to talk about the family of AI use cases and the various approaches in order to do AI within those industries. And we're also going to talk about a process that you can verify the work. And I think that's a strong distinction that a lot of people that have come through AI from a data science background are a bit more unfamiliar with. Whereas from an engineering background, you'll see that there's always a need to show your work, show your proof, show your results, and justify how you were able to come to those results. Who am I up here to really talk about these processes and these technologies? Well, our main company has been doing AI consulting for about 10 years with a strong affinity in various regulated industries. We're talking about aerospace and defense, we're talking about finance, we're talking about medical device and pharma, we're talking about energy, oil and gas. We were part of the largest ever scale AI project with McCain Foods. So we built an observation layer on top of their energy recovery systems. And the fact that we treat AI engagements as engineering projects through our background, we'll talk a bit about that later. There's a reason why we use these approaches to implement AI. About myself, I've been a consultant for about 10 years, especially with this company. Our core company has not raised any funds, but our spinouts have. A lot of our clients and partners have. So we were able to help raise 8 figures for a few clients multiple times just by being their virtual AI team. And myself, I'm also a licensed professional engineer. Also licensed as ISO 42001 lead auditor. Huge bias on the presentation, but again, we'll be able to clarify what we're going to be crossing. The agenda today, we're going to look at what is happening around the world. What are the emerging AI regulations? Spoiler alert, nobody knows. There's too many things happening. And we'll talk about even the trackers started giving up on trying to keep up to date with all of these emerging regulations. So what to do in this context when there are new table regulations coming out every day. We're going to talk about the specific perspective of machine learning engineering And I know a lot of people call themselves data engineers, machine learning engineers, but now we're really going to emphasize the fact that there are some engineering methods in place. And why is this relevant today? Why should I actually go back to the office and say, hey, you know what? I saw this presentation, I saw 4201. I think we should move on this. Being able to substantiate that is what we're going to talk about. Key takeaways, if you just need to get the TLDR, very simple. One, highly likely that a standard will be used as a prescription for adopting AI. Rather than having a framework or having a regulation, you can actually reference a standard. The second thing is engineering methods from other industries are highly applicable to doing your day-to-day activities. And finally, there exists a mature, auditable, and enabling standard available right now that can support the acceleration of work. So a lot of people think that a lot of standards, a lot of paperwork make things more difficult. I would argue that having a structured method will actually help you grow your team because everybody's going to do the same thing the same way. So you can be very creative and very explosive in your thinking if you know what are the systematic approaches that you are accountable to. Number one, merging standards from around the world. Obviously, everybody here has learned about the EU AI Act. Is anybody up to date with C27, C5, and all the changes happening right now? Any show of hands? Okay, so there are some new regulations that are coming out in Canada right now. There are some other regulations that are happening out of every single state. Some of the most aggressive regulations are actually coming out of Texas, of all places. Texas that is usually known as having a lot more lax approach to government affairs. And generally, if we have the perspective of trying to participate and comply with each and every one of them, it's going to be difficult for our entire team to just try and understand what are all the prescriptions. So AI is getting regulated, lots of regulations. We know that the EU AI Act has certainly broken the dam when it comes to being able to impose these rules. And there's a lot of trackers around the world that try to keep up to date. A lot of them gave up. IAPP, I think their last update was September 2024. Zurich Universitat, they were, I believe, December or January of just recently. And there's so many things happening. How do we even go about making these make sense? So AI regulations are far from standardized. Everybody knows that. Everybody tries to embed the culture from the geography in a way that is representative. The IEPP says the International Association of Privacy Professionals, which is a nonprofit, they say there's actually no standard approach from what we've seen. Looking at all the regulations, no one's doing it the same way. We also know that every jurisdiction is trying to balance the innovation aspect and the commercialization and the economic growth potential of AI, while at the same time balancing against risk. So some countries are more lax, some countries are less lax. So there's not the same framework going on around the world. And however, there's a start where if there is a national strategy, we have the AI strategy, we have the other approaches, then there's usually a set of laws and regulations that stem from that. So how do regulations impose technical regulations, which is usually the process that we're going to be seeing here? We know that a lot of people that aren't necessarily versed in AI are going to try to pass AI laws. Is there a way for them to actually do this? Well, there is. So, story number one. Back in 2018, our team with MNP won the first ever Canadian pan-departmental project with MNP to identify third-party incorporations by reference. This was before the AI supplier list, and this was right after the Phoenix audit, which, if you guys have a chance to read it, it's called $1 billion incomprehensible failure. Google it. It's quite a violent read. So we came in trying to sell AI with a lot of people that were really receptive to IT innovation, but we delivered. So the core term here is incorporation by reference. How do I take something that exists and put it into law through association? Well, incorporation by reference, it simply means I'm going to include this document. It's usually a legal mechanism for deferring the obligation from a technical standpoint to people that are experts in the industry. And it's heavily used in science and engineering. So the medical device regulations calls upon ISO 13485. All the public safety and occupational safety hazards, talk about the type of standards for elevators, for freight, for escalators. So we know that that process exists. And the fact that it takes about 1,500 person hours to review these documents, update them, is why this project came about. We know that Canada, the US, the UK, EU, UAE, Australia, a lot of these countries have a mechanism to do so. So if we look at where we're at and looking around the world, we know that these countries and these jurisdictions have a means of adopting these standards in a way that makes sense. If you guys want to look up the story, I have all the code, the model that we use and everything up here, but we were able to deliver a project, just as Canada said, that they trusted our tool, that we had found every third-party reference inside the standard, and they were happy with the work that we were done. Still to this day, not deployed, because this was the project that did not have a contractual obligation to actually spin it up on a server, just give them the source code. They still haven't deployed it. So if you want to talk about government innovation, it's a bit of an oxymoron. So typically, when a new law comes about, it will call upon a regulation. The law talks about what is everything that needs to get done. The regulation talks about the specifics. You need those two things in order for the standard to start being incorporated. When you're talking about standards, you also need a standards definition organization. So we have ISO, we have ANSI, we have NIST, we have CSA in Canada, an organization whose job it is to define, specify, and update and collaborate with all the experts in the industry to come with an agreed upon set of principles that can be put into a document. Followed by the notified body, BSI, we have a few others, whose job it is to be expert enough to be able to audit the work. So we have the law, the regulation, the SEO, and the notified body. So if you want to adopt a standard by reference, you need those four things. The difference between governance and compliance is actually quite straightforward. We want to make sure that whatever we build, if it's not complied with, has certain penalties. Otherwise, there's no need to force people to comply with these standards. Takeaway number one, highly likely that a standard or families of standard will be used as a prescription for adopting AI. Moving on, rise of machine learning engineering. We know that AI is becoming machine learning engineering because engineering, usually defined as the risk-aware application of scientific principles. If you start a project with your objectives, your requirements, your measures of success, and you're building towards an objective, that's an engineering endeavor, as opposed to exploratory data analysis, which is usually the step before. That's more of a scientific endeavor, trying to understand more of the problem. Where AI starts having a bit more weight in its audit and traceability mechanisms is when there's a social expectation of reliability. I would like that any self-driving car that I'm in or self-flying plane has a model that has been verified, and should anything go wrong, be eventually audited and retraced. I want to know what's the version of the model. I want to know what, who signed off on this and what is the process associated with it. We also have seen that the mechanisms in regards to deploying safe and secure AI are now much more understood. We know that MLOps is now more of a reliable set of activities that are much more systematic. And first time that we talk about this, ISO 42001 provides an effective oversight of AI-enabled systems. That's interesting. So how do you build a solution within a regulated industry? We'll talk very quickly about an example, my previous career in medical devices. Let's say you have a great idea about a few scientific papers that come across. First, you say, hey, we found this research. Looks like we can do something. And with our research, what we found was if you take gentle direct current stimulation, called transcranial direct current stimulation, you can actually provide curative treatment to addiction. Not something that we've ever seen in that medical field. So you come together with a bunch of your friends and you say, you know what, we're going to launch a company, we're going to investigate this, we're going to build a product. What is it that is required for you to be able to put that device out in the public? Well, not only do you need to make sure that everything that you built is up to par and you have all the manufacturing standards, but all of the management, all of the third parties, and everybody involved in the shipping, the testing, and the training has also been vetted. This means that that process can be quite hefty if you're not ready for it. These are some of the certifications that we had to achieve. There's a bunch more that are very jurisdictional, so on a per country basis, on a per deployment basis. Even the difference between Quebec and Ontario, we had to get different certification. It's quite cumbersome, but what we had to do was build a device that gave us not only some patents, not only some clinical trials, but we were able to build it and deploy it and make sure that everybody trusted what was built. So we needed a strong foundation to ensure that we had the ability to build something reliable. The way you go about building it is you look at your requirements, you look at your objectives, you look at your measures of success, verification, validation, ongoing monitoring, you even have a way to retire it. Hey, wouldn't it be great if we use these principles whenever we build our AI systems? So I'm sure that a lot of people think about a lot of legacy models that are just kind of floating around there. Nobody knows what's going on. Your chief AI engineer leaves and you have, I don't know what your AWS costs are per month, but you can't shut it down because no one knows what's going on. Well, maybe there's something that we can do about that. Engineering methods from other industries are applicable to building reliable machine learning systems. This is a very wordy way to say, think like an engineer, think in a structured, stage-gated approach, and now suddenly things start making sense. Third, why adopt new standards now? A lot of you are familiar with the NIST AI Risk Management Framework. You have a number of other frameworks. You have vendor-provided frameworks. IBM threw their hat in the ring. They tried to do ethical AI. We have a bunch of other players that want to prescribe not only that there are some risks out there, but really their technology is the only technology that can actually solve this problem. And obviously, everybody knows here that that's not true. We just have to say the quiet part out loud sometimes. So AI is still not a repeatable process to create value within organizations. We think about what exactly happens when we think about AI. We think, oh yeah, we're just going to turn it on, we're going to connect it to the data, it's going to work. Well, it turns out that it's a lot more difficult than that. This is the first report that I could find. 80% of AI projects fail. Depending on what you Google, depending on when you Google it, you're going to float somewhere between 60%, 70%, 90%, 92%, depending on the various perspectives. And if you look at some of the papers on SSRN and Archive, what you'll see is depending on the industry, depending on the projects, what constitutes success, what constitutes failure, bounce around. But the idea that it's 80% and not 20% should alarm a lot of people. So have we seen this pattern before? Have we seen where historically there have been some other issues when it comes to trying to establish a systematic approach to derive value from a new and emerging technology? Well, turns out that the 1960s had this thing called the software crisis. Who here did software engineering and read about history of software engineering? Few people? Good. So big problem. After World War II, people had all these massive computers. Computers showed a lot of potential, but every project was failing because people didn't understand how to really build a system, manage a team of people, and make sure that it was brought together. So one of the quotes, and when I share the slides, the source is there, 1960s computer industry was experiencing rapid growth, leading to increasing complexity in software development, characterized by projects that were over budget, overdue, and unreliable. Does this sound familiar to what's happening right now to large-scale AI projects? I hope everybody can resonate with this term. They're saying, oh, you replace software by AI. It seems the same thing. So NATO, 1968, 1969, decided to organize a bunch of conferences to say, guys, this is actually a national security risk. We need to come together and solve this problem. So they said, why don't we treat it as an engineering endeavor? And they were called the NATO Software Engineering Conferences. That was the first worldwide use of the term software engineering actually came from these very specific conferences. So as we're talking about the emergence of machine learning engineering, there are actually some parallels from a few decades ago that talk about how do we go about implementing these systematic approaches. Going back to why adopt new standards now. We know that a lot of the AI frameworks don't really have a lot of penalties associated with them. So You can implement them on Monday, everybody's happy, everybody feels good, but is anybody going to pull the fire alarm should a model have any issues? Not really. There isn't really a mechanism. Okay, we'll fix it. You know, we'll write an internal memo, like little whoopsie. We'll see what happens. But this becomes a lot more critical if it's on a plane, if it's in a car, because oftentimes at the edge you don't have the ability to dynamically update the models. You don't have CI/CD. Instead, what you have is a model that gets puts in the box. The box gets put in the plane. The whole thing gets certified, and then any change, whether you tighten a screwdriver or update a file, the entire plane needs to be recertified, or at least within the risk profile. So we know that we can't really rely on AI governance frameworks to be able to move the needle or give us the assurance that we need when it comes to our regulated AI systems. There are new standards, ISO 42001, which integrates with existing quality management systems. If you work in a lot of these industries, what you'll see is you'll come with a quality management system in such a way that this particular standard can just shoe in. So the reason ISO built it this way is because it can align with all of the other ISO standards. There's a lot of criticism with ISO as a whole, but this one in particular has been quite good. If you guys are technicians, one secret takeaway from today is ISO 22989. So that talks about the AI system life cycles. It talks about how you should stage gate your AI ML deployments. ISO 42001 integrates nicely with 9001, 13485, so medical devices. If you build an AI-enabled device, you can just shoe it in. Our hypothesis is that the German MedTech sector is actually going to be the first to require an ISO 42001 imposition for any type of AI-enabled medical device, just based on the history of the country, based on the history of the regulations. Defense is going to be separate. They're going to try to do something a bit later. But overall, we think that the ability to implement ISO in these industries is going to go through this process. If you look at this graph and you are familiar with ISO, you'll see it's the exact same graph. The only difference is besides the AI policy and AI objectives, there's AI risk assessment, AI risk treatment, and AI system impact assessment as part of the process. But usually these audits are on a quarterly or yearly cycle, depending on if you do internal versus external audit. And the rest of the organization that already follows these auditable processes will be used in order to continue the work, which means if you're already going through quarterly audits, yearly audits, you can actually just do an ISO 42001 audit at the same time. Are these standards worthwhile? Well, if you build an AI system, let's talk about the 8 things you need. Robustness, reliability, resilience, controllability, all the way down to bias and fairness. If you deploy an AI system, are you sure you've taken these 8 factors into consideration? Well, Matt, I'm deploying LLMs inside my medical device. I don't have a lot of explainability. Okay. Well, if you're concerned about human safety or given the risk profile, does that account for the type of model that you actually want to put inside a medical device? Finally, we also know that there are some issues and some misalignments between ISO 42001 and the EU AI Act, but those are usually details and interpretive differences. So for example, prohibition of certain practices, EU AI Act has a big prescription, whereas ISO 42001 really talks about the AI policy, all the way down to the post-market monitoring. Usually it's definition differences and the mechanics surrounding the process. So if you have a model that is considered high risk, there is a lot more imposition from the EU AI Act to have a lot more structure and scaffolding around it, whereas the ISO 42001 will simply defer to the AI policy and make sure that whatever you do is in the AI policy. So small details, but again, very important to consider. So final question here, and this is something that we've seen especially in Saudi Arabia, UAE, and a few large European banks. Question is, how do I grow my team to 100 machine learning engineers? Do we just hope for the best? No, there's actually a process. So the way you do it is first, you look at ISO 42001. You say there needs to be executive accountability for making sure that everybody knows what needs to happen. we need to make sure that we commit to establishing a process. There's also a special mention here of maintain accountability without career risk. That's kind of the validity of using ISOs. You can say, no, it's a non-conformity rather than me having to quit my job. From ISO 42001, you can actually start today implementing ISO 22989 with your AI project lifecycles. So how do you actually go about making sure that your projects are stage-gated and deployed in a safe and secure way? And then finally, you can actually integrate ISO 22989 and ISO 42001 as part of your MLOps. What we found is, working with a few clients, we've created an open source on-premise and extremely modular MLOps process that can switch between your preferred cloud providers, between your different data providers, and ensure that the entire approach can actually be quite systematic. So, takeaway number 3, there exists a mature, auditable, and enabling standard that can support the acceleration of work, ISO 42001. Conclusion, I'm just going to repeat the last terms. 1, it's highly likely, based on the fact that incorporation by reference is a thing, that jurisdictions around the world are going to adopt either this particular standard or a standard close to it. Takeaway number 2, we know that if we think like an engineer and we structure the process in a stage-gated fashion, our ability to comply with very specific industries is much easier. And finally, there exists right now a standard that you can take back to the office and say, you know what, we should start working on this. Thank you.
We do have time for one question.
Firstly, thank you for the timely talk. It was pretty concise, putting all the information together. So my question is, does this standard also apply to business critical systems? Because even if they are not in the medical devices, the enterprise business systems, if there is something goes wrong, we have seen how airlines, they cancel the flights and so on and so forth. So they underlie the economy significantly. So do you see this standard also applicable for business systems? Thank you.
Business systems can be defined in multiple ways, but I'll take a very specific perspective through cybersecurity. So ISO 27001 is one of the standards that ISO 42001 can attach itself to make sure that the rest of the processes are well followed. ISO 27000 does have a lot more prescriptivity in the type of processes that are required, and so there is already some audit cycles, and we've seen that being able to talk to the same people that are both doing the IT operations as well as the data management seems to have faster path to implementing or updating the processes and procedures that are required for safe and effective work. When it comes to the disruptions themselves, the types of problems that we've seen are usually avoidable. So we came in a few times in what can only be described as a rescue operation, where, like I was talking about earlier, the chief AI engineer leaves, there's a bunch of containers running, no one knows what's going on, there's no README files, nothing's documented. And how do you actually reverse engineer that process to understand actually what's going on? Oftentimes, that's what's required to be able to approach it. So to your point, what we've seen is there are still, from business critical systems like CMMC, ISO 27000, and a few other cybersecurity frameworks that are not yet fully meshed in, but we find it easier to give people structure and guidance that is from an external reference that everybody can align around.